Dear all of my students for the class CMB 27E as a network class, let's go today with chapter 8, which is the network security. When we go with the network security and starting by using the network security, we will remember with each other that for the first few decades of their existence as a computer network were primarily used for university researchers for sending email and by corporate employee for sharing printer. It means that the initial using of the computer network, which started as a network connecting the research center in the university, exchange email between these university and messages, and also use the network to share the resources as a printer inside the university. Under these conditions, security did not get a lot of attention. There is no attention for the security at that time. But now, as a million of ordinary citizens are using the network for banking, for shopping, for filling their tax return, and weakness after weakness has been found in the network, network security has become a problem of massive proportions. That's why in this chapter we will study network security from several angles, and we will discuss many algorithms and protocols for making network more secure. If you go with the network as a infrastructure, we will go with each other, or we will see that the network security has two categories, what we call vertical orientation security and horizontal orientation security. When you go with the vertical orientation security, we will go to secure the layering system or secure through the layering system in the ISO standard or TCP model. TCP, Transmission Control Protocol, Internet Protocol model. That's why we have on the vertical security, we have on the third layer, we have what we call IPsec. In the fourth layer, we have what we call secure socket layer, transport layer security. On the fifth layer as an application layer, we have security for different application over the application layer. As an example, which secure MIME as a secure multi-purpose internet extension, which is the security of the email for multimedia. And the horizontal orientation security, which securing end-to-end communication through the securing the routing table over the internet as a routing protocol, which advertising the routing table. That's why we would like to secure the routing table over the internet, routing technique. And then we have the secure boundary of the organization through what we call firewall. Then we have vertical orientation security and horizontal orientation security. When we go with the network security, as in the chapter 8, they go through sequence of discussion about the cryptography, what's meant by cryptography. Then through the cryptography, which is encryption and decryption, we will go with the symmetric encryption technique as a symmetric key algorithm, and we will see some example, and the public key algorithm, which is the asymmetric encryption technique, digital signature, which is related to non-repudiation, management of a public key, and so on. Say, for example, here an application layer security, email security, authentication protocol, which can be used for the third layer security. It means that we will introduce with each other different issues related to the network security. Then when we go with the network security, security concern a variety of threats and defense across all layers. Then across all layers of the TCP/IP protocol, we would like to have securing that layer. Like I told you, we talk about the vertical orientation security. On the IP layer, IPsec, transport layer, secure circuit layer, transport layer security, and the application layer we have secure electronic transaction, securing credit card over the internet, secure email, securing the email over the internet. As a cryptography is a fundamental building block for security mechanism. Let's go back to the ISO security. We go to the ISO security and we have main three issues, what we call security services, security mechanism, and security attack. Security services, which is a service offered to secure your system, which is confidentiality, data integrity, authentication, non-repudiation, and access control. Then security mechanism, which is the mechanism is used to develop that security services. Then we talk about what we call symmetric algorithm and asymmetric algorithm. Then go back here for the cryptography here, which is the fundamental building block for security mechanism. Then the mechanism is used for encryption, decryption, and develop the service security services over your organization. Then we will go with the different technique used for encryption and decryption as a substitution cipher, transposition cipher, and then we go here. This is the general block diagram for encryption. The encryption model for asymmetric key cipher, which you see here. This is the plain text at the input, and then this is the encryption algorithm using the K key. The output will be the cipher text. We have here the cipher text equal to the plain text encrypted using the algorithm and the key used for encryption, which is K key. And then the message goes through the transmission media or the network, and then you go to the decryption at the receiving side. Then the decryption using the same key, since we are talking about symmetric encryption technique, then the same key used for encryption and decryption. And then you have the output here, which is the plain text again. Then this is the general block diagram, which is used for encryption and decryption for using symmetric encryption technique. But you see here as an intermediate here, which is the transmission media. This is the network. Then through that network here, you may be attacked. That's why we talk about the attack in the main three issues of the ISO standard. Then we have passive attack and active attack. This is the passive attack. It means that the intruder is monitoring only the information transfer and no change, no damage for anything, but just to get benefit from the information. And then you have here the active attack or active intruder, which may receive and delay the information, may receive and damage the information, may receive and change the information. Then as an introduction, this is give you the general block diagram for the encryption decryption using what we call symmetric encryption technique. You will go through the textbook and the material explaining for you the substitution cipher and then the transposition cipher. Then this is a simple approach for security or change from plain text to cipher text. This is the simple approach for securing your information. If you go with each other here as a symmetric encryption technique or symmetric key algorithm, then encryption in which the parties share a secret key, then the source and destination using the same key for encryption at the transmitting side and decryption at the receiving side. Then as an example for the symmetric encryption technique, which is the famous one used, which is data encryption standard. And then due to the technology, they come with the new algorithm, which is advanced encryption standard. Then both of them are symmetric encryption technique used for encryption and decryption. If you go through the material, you go with the symmetric encryption technique. You will see here the symmetric encryption technique going through the algorithm, which you have the input plain text here, which is 64-bit data divided into two blocks, 32 and 32, left hand side and right hand side. Then goes through the algorithm through what we call 16 round. That 16 round, each round they have a repetition and encryption for the left hand side and right hand side, starting by initial transpositioning and inverse transposition, and in between you have a different iteration for the 32-bit as a left hand side and right hand side. This is simplified block diagram for the data encryption standard. As a data encryption standard, you can use it as multi-stage, what we call triple encryption, 3 data encryption standard with two 56-bit keys. As you go back here, if your input data is 64-bit as a block of data, the key used for encryption and decryption is 56-bit. Then here they may start to make use for a complication to against the attacker from outside. Then they use triple data encryption standard. For the triple data encryption standard, they have a plain text here, and you have a complete data encryption standard algorithm here using K1, and then again the output, this is the plain text, the output is cipher text, say C1, considered as an input for the second stage of the encryption using K2, and then go with the third stage of encryption using K3. Then this is triple data encryption standard using 2 key, and here the output will be the cipher text. Then go in the receiving side, the cipher text will go 3 stage here to get the plain text again. In this case here we say triple data encryption standard using 2 key, and I think that there is another technique used what we'll call triple data encryption standard using 3 key. In this case it will be K1, K2, K3, and also here K3, K2, K1. Then you can use the data encryption standard 3 times to make a complication for encryption and decryption. Then go with the advanced encryption standard with the new techniques used for encryption. Then if you look at here, symmetric block cipher key length up to 256 bit. It means that the key length in the data encryption standard here, it's 56 bit. And here as a complication, it can be up to 256 bit. Then the advanced encryption standard, which is openly designed for public competition 1997 to 2000. This is the new technology or the new algorithm for symmetric encryption technique. This is some explanation for the advanced encryption standard. Let's go here with the public algorithm. Public key algorithm here, which is asymmetric encryption technique. It means that encryption in which each party publish a public part of their key and keep secret a private part of it. It means that the public key encryption technique is asymmetric encryption technique, which is using 2 keys for each user. 1 key as a public key, which is published for all users, used for encryption, and the private key used for decryption. It's used only by the owner of that key. That algorithm, as an example, we have what we call RSA algorithm, which is invented by Rivest Shamir Adleman. In this algorithm here, as a public key encryption technique. This is some mathematical calculation